Hi everyone. Okay, people are joining.
Excellent.
So I would say let's start. We have a full session today. First of all, thank you for coming to this first session, the first breakout session of the summit. I'm really happy that we are the first one to introduce you to the fundamentals of AWS networking. Why? Because networking is the base of everything, and you know that. In this room, I expect we have some network engineers, some infrastructure architects, people who love networking and infrastructure, people who are new to the AWS, but also people who have already deployed thousands of VPCs, maybe? Someone in that space? Yeah, hopefully. So this is a 200 level session. In case you don't know, 200 in AWS terms means intermediate session. I'm going to focus on the fundamentals of VPC, of the AWS VPC, what you need to know in order to start building on AWS. So that is great for the ones of you who are beginners in this space. But I also be talking quite a lot about the innovations that we had last year in the networking space, especially related to the VPC. And that for the ones of you who are already advanced in deploying networks on AWS, you might find that useful. If this is not the right level for you, you still have the time to join another session. My name is Corina Motoi. I'm a senior solution architect focused on hybrid cloud solutions for AWS, working with customers across EMEA. And with me, I have Radek from ARM. In the last part of the session, he will take us through how ARM has innovated on AWS, how they took those fundamentals, they took our innovations, and they have quite a cool architecture that Radek will share with us. So let's get started. We have less than 45 minutes, and we have quite a full agenda. The beginnings of AWS networking was actually in 2006 with EC2 Classic. I seriously doubt that any of you have worked with EC2 Classic. Or, yeah. And, oh, thank you, one, perfect. And that's fine because in 2009, we have launched the Amazon VPC. Amazon VPC, it's your own piece of AWS cloud, exactly like you have in the data center. And with the Amazon VPC, we are going to learn how you can design your environment, because that's the fundamental structure that you need to be aware of when you're working with networks. So in the Amazon VPC, you have what is called subnets. And you have one or you have multiple subnets depending on how you want to split your workload. The subnets, even though the VPC is a regional construct, the subnets are availability zone construct. Again, don't forget that when you're designing on AWS, you want to design for high availability. Hence, the concept of availability zone should be quite familiar to yourself. The first thing when you're designing your VPC, which again is your piece of AWS cloud, you have to define the CIDR, the addressing, the IP addresses that you're going to use. And so far, we are supporting both IPv4, IPv6 only subnets, but also a mix between IPv4 and IPv6. So you have this flexibility to design your VPC however you want. What is important to know is the fact that the VPC CIDR can't be modified once you have created. So for that reason, a very good IP strategy is quite necessary. And for that, we launched a couple of years ago Amazon VPC IP Address Manager, which makes your life easier in order to manage IPv4 and IPv6 addresses at scale. The innovations in this space, because again, it's a tool that we have launched a few years back, and we have innovated in the sense that now you can integrate the IPAM, the IP Address Manager, with accounts outside of the AWS organization. Especially if you are into mergers and acquisitions, well, now you can expand your IPAM. And another one which I really find cool is the fact that now you can gain detailed insights into the IP address utilization metrics. We have put together this great tool visual. Visual is always the best when it comes to monitoring and troubleshooting even. And now you can actually see, okay, what are the CIDRs that I have? Are they compliant with my regulations? You can even add additional details to it, and you can see the utilization of those IP addresses across subnets, across VPCs, and you can take decisions based on it. I think all of us, we have the problem with the public IP addresses, with maybe adopting IPv6, and this is a tool which can help you influence and take decisions on that. If you haven't tried IPAM so far, please do, because now we do offer a free tier. And in the free tier, you will have the public IP address planning features within the AWS account and the region where the AWS Amazon VPC address manager has been created. And also you can provision with the free tier, you can provision Amazon contiguous IPv6 blocks or even bring your own IPv6 blocks. So you have this option now within the free tier. For the ones of you who already have used IPAM, you will see that you have now been upgraded to advanced tier, in case you haven't noticed so far in the console. Once we have the addressing, you have created your VPC. You're ready to go. And then, okay, what are you doing with the VPC, just the VPC in the AWS cloud? You are start thinking about the connectivity piece. And the first thing that our customers do is actually connect that VPC to the internet. For that, you will need to add a couple of constructs to your VPC. If you're using an IPv4 space, you will need to use what is called the Internet Gateway. It's a logical construct. You attach it to your VPC. And the instances that you are launching in your subnets, based on the route table that you associate to that subnet, will be able to talk to the internet via the Internet Gateway, as long as they have a public IP address or an elastic IP address. For the IPv6 space, you have what is called the egress-only Internet Gateway, and no elastic IP is needed for that side. Those subnets which talk to the internet, they are called public subnets. Well, you don't always want to have your workloads talk to the internet. So for that reason, you can have private subnets. Those private subnets don't have a direct connection to the internet. You will basically need to have a route table directing traffic to what is called the NAT gateway. And then the NAT gateway will carry forward the traffic via the Internet Gateway to the internet. So this way you can keep workloads private in a private subnet. NAT gateway, it's a construct which our customers love, and so far we were able to have up until 55,000 concurrent connections to a unique destination. But you will see once you grow, 55,000 is not such a high number. So for that reason, last year, we have managed to increase that number of concurrent connections 8 times. So now, in case you're using a NAT gateway to carry your traffic forward, you can have 8 times or 55,000 concurrent connection, which is a huge increase of scaling your traffic out. How you're doing that? You're just adding additional IP addresses to your NAT gateway. We have the connection to the internet. Let's look in the cloud. You will have more than one VPC. You would want your VPC to connect with other type of services. And the first one which you should look at is the private link. Private links allow you to connect the workloads in a VPC to services powered by private link, a private connectivity to other services. How you're doing that? You're just dropping an interface endpoint in your VPC and traffic remains private. You can connect to services which are already defined, like the AWS services, privately via the private link, or you can create your own services. This is especially common architecture if you are a partner or if you have an application which you want to have it accessible for multiple other consumers, because you are creating your application in something which is called service VPC or service provider VPC, and you are interfacing that application by private link with an interface endpoint in the consumer VPC, the VPC that you want to have access to your application. It's a great tool, it's a great service from AWS. Just keep in mind that using private link is a unidirectional traffic. So that is one thing to keep in mind when you're planning for this type of architecture. What we've done with the private link, the moment when you're using private link, in order to actually use the private link, you have that interface endpoint in your VPC, which takes one of the private IP addresses that you have in the VPC, which is great. But what is even better is the fact that now you can actually allocate yourself those IP addresses. So you don't have just a random IP address allocated. You can decide which IP address from that particular subnet you want your interface endpoint to have. And that is particularly useful when you need to whitelist on your firewalls or on your premises environment the services interfaced by the interface endpoint. Moving a little further, we've talked about the private link as offering unidirectional connectivity. Well, you will have more than one VPC, and most probably you will have more than one region. And you want those VPCs to talk to each other, bi-directional communication. For that, I would totally suggest to look at the VPC private link, peering. VPC peering, it's a private connection between two VPCs, can be in the same region or can be in outside the region. And the great thing is that the traffic is private, always stays on the AWS backbone when there are no bottlenecks, and you won't have any problems from the security point of view. VPC peering is great, but you will scale beyond a few VPCs. And the next step that you will probably consider is the AWS Transit Gateway, which is a virtual central hub. It's region specific and allows you to have up to 5,000 attachments with. When I say attachments, they can be VPCs or they can be even direct connect VPNs. We will talk later about it. But it can scale. And the way how you are directing the traffic between all these thousands of VPCs connected to the transit gateway is via the route tables. You can have the routes propagated from your VPCs, or you can enter them manually. You have this flexibility depending on how your regulations are. And it allows you to route both IPv4 and IPv6. So whatever you're using, we can route that via the transit gateway. How actually it works? Each attachment that you will have to the transit gateway will be associated to a route table. You can have multiple route tables on the transit gateway, depending on how you're segmenting your AWS environment. What is important to know, when you're going via the transit gateway route, doesn't mean that you don't have to look at the VPC peering or the private link. Not at all. Actually, the best architectures are the ones where you mix and match. And I will just give you an example about transit gateway and VPC peering, which is one of the architecture that I always recommend to the customers I talk to. It's great that you are using transit gateway, makes things so easy. But if you really need that extra low latency, if you have between two VPCs quite a high throughput, please have a look at the VPC peering. Don't underestimate the power of the VPC peering. So definitely mix and match is the best. Probably you have a solutions architect that you're talking with and always says, it depends. Exactly, it depends on the use case that you have. Now, we've talked about the cloud. Let's go out of the cloud and talk about the hybrid connectivity, my special part. When you will be starting with AWS, most probably you will have an internet connection and you want that to be secured. So for that reason, we are offering the AWS side-to-side VPN, which basically is a pair of IPsec tunnels which run over the internet. And it can get you will get 2 tunnels for redundancy. Each tunnel can carry up to 1.25 gigabits per second, which helps, and encrypt the traffic, of course. But that bandwidth might not be enough. Over the internet might not be good enough for you. So for that reason, we have Direct Connect, AWS Direct Connect, which basically gives you a private connection between your data center and your environment in the cloud. If you have a single VPC, then on that direct connect, you will probably have a private VIF, and you will attach it to a virtual private gateway attached to your VPC. If you have multiple VPCs, and I'm sure that will be the case when you are going to consider the direct connect, you will get to know one of our constructs, which is called Direct Connect Gateway. It's a global construct. That means you can associate VPCs from all the regions to that Direct Connect Gateway. So basically, you would have your data center in London, but you will be able, via a single Direct Connect link, to access VPCs in New York, Mumbai, Australia, or wherever, which is a really cool feature. And because it's such a cool feature and our customers are actually using it, from 10 VPCs that you could associate with the Direct Connect Gateway, now we have increased the number to 20 VPCs associated with the Direct Connect Gateway. And this helps because you can delay the moment you're using Transit Gateway, but you can't delay it forever. So for that reason, Transit Gateway will come into play once you will have more VPCs and you want those VPCs to talk to your on-premises. And for Transit Gateway, we do support VPN attachments, so you can have a VPN connection from the on-premises to the Transit Gateway. That's perfectly fine. The good thing is that we support ECMP, so you can increase that 1.25 gigs per VPN connection when it comes to the Transit Gateway. But in the same time, we support Direct Connect. And you would have a Transit VIF configured on your Direct Connect that will go to a Direct Connect Gateway and then to your Transit Gateway. And we have increased our limits there because we are seeing that our customers are scaling. So we are trying to keep up or to be an innovators in that space. So now on your Direct Connect, on your dedicated Direct Connect, you can have 4 Transit VIFs that you can configure. And going even further, to each Direct Connect gateway, you can now associate 6 Transit gateways with it. So you can scale your environment pretty large. Let's not forget each Transit gateway up to 5,000 attachments. So imagine how big you can go on with AWS. And this is my favorite feature because all my customers have requested it in the last few years. Now we support 200 IPv4 and IPv6 prefixes propagated from AWS to the on-premises. I'm sure that whoever has used Transit Gateway up until last year, they struggled with the 20 limit that we had, but now we have 200, which helps a lot our customers. Connectivity to the on-premises is great, but our customers most of them, they already have SD-WAN deployed on the on-premises and they want to integrate it with the cloud. So for that reason, we have what is called Transit Gateway Connect, which basically established a connection between the Transit Gateway and the VPC where you are deploying your third-party SD-WAN appliances. And in this way, you are extending the SD-WAN from the on-premises to the cloud. The Transit Gateway Connect, it's actually running GRE encapsulation, which helps you with the high throughput, and uses BGP for the routing part. Transit Gateway is great, but it's a regional construct. Don't forget, you will go further than the London region or Ireland or I don't know where you're using. You will use multi-regions. And you would want to have that global network. You will want to have everything managed and monitored, hopefully from a single pane of glass. So I totally advise to have a look at AWS Cloud One. Makes it easy to build and operate such a global network. Cloud One, again, it's a multi-region. It's a service that is perfectly fit for multi-region deployments. It uses the AWS backbone to connect the regions between them, of course. And you can deploy it quite easily. You'll see by just using a core network policy, so it's all scripted, JSON policies, pretty easy. And the great thing, from my point of view, about Cloud One is the fact that you can use segmentation. And you can use segmentation not in a single region, how you have with the Transit Gateway, but you can use across region, across on-premises as well. The components of Cloud One, I'm not going to talk too much about it because we have so many sessions from last year, but just want to make you aware we have the core network policy, which is that part which makes easier to deploy. You have a JSON policy and you define, okay, what are the regions that I want to use, what type of segments. Segments are the dedicated routing domains across all the regions, and only the attachments to those segments can communicate between them. So you can have that segregation of traffic across regions. And you define how you want those segmentations to be. For example, you have here a production and a development segment, and you say, okay, whatever attachment I have, which I'm tagging it with production, please add it to the segment called production, but only after I approve it. So that far you can go with the decisions. Based on that policy, we said we want three regions. That means underneath, AWS is going to build what is called core network edge, based on what we defined on the policy. And those are connected via, they will exchange routes via BGP peering. Underneath are like Transit Gateway, just for you to understand how it works. And then you will have the segments that I've talked about, which you can extend across all your regions, or you can have it on a single region, in two regions, and so on. You are defining how you want your routing domains to work. Once you have defined, okay, those are the regions that I want, these are the segments, you start adding attachments, similar to what you have in the Transit Gateway. And you can have VPC attachments. Or you can have the third-party SD-WAN appliances that we had for the Transit Gateway. You can have those ones directly attached to the Cloud One. They will be via the VPC attachment, and of course we support GRE encapsulation on top of them. But what we've launched last year is tunnelless connect attachments. So we take away the overhead by having an encapsulation on top of the VPC attachment, and we give you the full bandwidth that you can achieve using a VPC attachment, which is up to 100 gigs. So if you do want that throughput when you're having your SD-WAN appliances attached to the Cloud One, I would totally advise you to have a look at tunnelless connect. Cloud One, we've discussed what you can have in the cloud, but again, it can connect to the on-premises. That's the idea of it, to have a global network. So it supports connectivity with direct connect via the AWS Transit Gateway. So you will have to have a direct connect going to the Transit Gateway, and then the Transit Gateway will be paired with the AWS Cloud One. We do support also native integration with a VPN. And actually, that's one of the cool things, because you can have all your branches being attached to the Cloud One and then having the traffic flow from one to another using the AWS backbone, which I find it a major plus. Now, looking at the application networking, we've talked about the connectivity part. We talked about designing the VPC. Let's look a little bit in what you can do in the VPC from the networking point of view. We have load balancers. We have the application load balancers at the layer 7, which basically load balances incoming HTTP, HTTPS requests. And that is great. One other thing which does lately, in the past, you have in traditional TLS packets, basically you have the authentication on one side. So the server authenticates itself against the clients, but the clients don't have to do that. So what we've done for the application load balancer, we've launched the mutual TLS support for it. That means you can add an extra layer of security by requiring both the server and the client to authenticate, and you offload that authentication to the application load balancer. In this way, you make sure that all the requests that go to the target are authenticated and you have that extra layer of security. Going a little bit further, another type of application of load balancer is the network load balancer. Working at the layer 4, basically you have both the TCP and UDP traffic that you can pass through the network load balancer, manages millions of requests per second. This is one of the greatest advantages of it. And what we've launched lately, last year, is the fact that in the name of security, of that extra security enhancement, we have security groups available now for the network load balancer. You associate that security, you can associate them at the creation time, and basically you make sure that all the, you can filter that traffic that comes to the load balancer and also leaves the load balancer. Furthermore, you can reference the network load balancer security groups in the target security groups, which makes it easier when you can reference that. One enhancement that we've done for both load balancers, so I mean the application load balancer and the network load balancer, is the fact that now we can support IPv6 instance type targets. As we can see, we're going quite a lot in the IPv6 world. I can't leave the application networking without talking about Amazon VPC Lattice. So we've talked so far about networking, how you can connect it. You have to know VPCs, you have to know direct connect, peering, all kinds of constructs. But with Lattice, you can abstract all those, and you can focus on the actual service. Sorry, on the actual service. Basically, VPC Lattice is a service which we launched a couple of years ago, or last year, which allows you to create logical application layers for your applications, for your environment. You define what is called service. Service is a piece of software which you choose to run on containers or Lambda or EC2, it's up to you. And those services, you attach them to service networks. The service networks allow that service-to-service communication. In this case, the client VPC being associated to the service network will have access to all the services App 1, App 2, App 3 that you have defined. And this way makes it easier for you to enable that connectivity without caring about the low-level networking infrastructure. I'm not going to talk more about Lattice because we have a full session coming. So if you want to know more about it, about the best practices, please stay in this room. Right after our session, our colleagues will talk about the best practices of working with Lattice. It's a really cool session. We had it in the keynote, we had it everywhere if you're following the AWS news. So let's see how GenAI can help also on the networking space. Amazon Q. Amazon Q is our GenAI assistant that you can use to troubleshoot your environment. Basically, you can just ask questions and receive answers in plain text where the problem is. For the networking, it uses VPC reachability analyzers under hood, so that's how it does the troubleshooting. But you don't have to care about the VPC reachability analyzers because you will be using only Q. So for example, let's have a, I wouldn't say complicated, but a pretty standard architecture, three-tier web architecture, which you have the web application and database layer, and each of them have security groups. Great. And what you usually say, the network doesn't work. Well, it's not. We have some problems, we will fix it. So how we'll fix it? The problem that we have is we can't SSH into instances in AZ1. Our application uses both availability zones. So for that reason, instead of me going into console and try to figure out where is the problem, I'm just going to ask Q. And for that reason, going into the console, you will see already, whoever is using the AWS console, you already have that little icon there for Amazon Q. Click on it and you just ask directly. Why can't I SSH into my web server in AZ1? Amazon Q, okay, will start thinking, and it will actually correctly identify the instance that we're trying to SSH into, because I've already, when I've created my architecture, I've said that that is the web server instance. Going a little bit further, Amazon Q goes to the VPC reachability analyzer and creates the full path, or the full analysis which is provided by the analyzer. And what does Q discover is the fact that there is no ingress rule configured on the security group associated with the web server in the AZ1. And they actually tell us which is the security group. So for that reason, we're just clicking on the security group. We're seeing that there is actually none. And of course, if there is none, you can't SSH to it. We're just adding the rule for it, and everything is easy. So pretty easy. We are using Q to just increase your productivity, speed up things. I would totally advise for you to try it. Just be aware the fact that it's in preview. So, and it's only available for the time being in North Virginia, but just have a play with it. It's only available from the AWS console, so you need to have access to it. And being in preview, we limit it to 20 questions per day, but it resets the second day. So with that in mind, we went through quite a lot. So we went through designing, we went into how to connect actually the design, how to troubleshoot, and now let's see how the customers are actually doing and how are they using all this. I will leave you with Radek.
Thank you. My customers are probably the most My customers are developing technology which is used by 70% of entire human population. My customers are also very demanding. They require the best solution. They require the solution to be delivered as fast as possible, as agile as possible. They require the solution to be feature-rich, and they require the solution to be delivered to allow them to modify this solution because they will need this modification as well. My role is to take AWS services, embed these services into solutions, take this solution and build an environment, and deliver this environment to my customers to support the brilliant job they are doing. My customers are ARM engineers who are developing ARM technology. Ladies and gentlemen, first, connectivity inside the cloud. In the beginning, we decided to be present in 4 regions, 4 transit gateways, each per 1 region, paired in mesh scenario, which allows us to have connectivity both inside the region, as Corina said, up to 5,000 attachments, but also provide connectivity between all 4 regions. Once the backbone in AWS has been created, we had to connect this backbone somehow to our data centers. And obviously, the easiest or the way to do it is site-to-site VPN. To be precisely, in our case, we deployed 4 site-to-site VPNs. As you can see, each site-to-site VPN was terminated on 1. Done to replace the site-to-site VPN from both sides. First, we replaced right site-to-site VPN with connect attachment. So generally, we replace site-to-site VPN with GRE tunnel. And the second, we deployed direct connects, 4 direct connects. On top of this, because we wanted our architecture to be as fast, as agile as possible, we use this direct connects as a fabric on top of which we deployed SD-WAN. and this SD-WAN has been deployed on top of solution delivered to one of our external partners. Now, before we even started to build configuration, we started to think how to plan IP addressation, because we wanted to give our engineers, our customers, the same experience in the cloud as they had on-prem. We started with simple pattern for IPv6, 2 availability zones. It's good to be in 2 availability zones because the probability that we lose 1 availability zone is very low, but it does not mean that it's 0. So 2 availability zones, each availability zone /25 gives us /24 per VPC. Since day one, we assume that we would like to have at least 100 VPC in each region. We rounded this to power 2. You guys are networking guys, so you know why we did it. So it gives us /17 per each region. And on top of this, because we wanted to be present in 4 regions, 4 multiplied /17 gives us /15. And this is the subnet which has been dedicated, private subnet, which has been dedicated to our environment in the cloud. With IPv6, situation was a little bit different, and there are 2 reasons for that. First reason is we did it 2 years after we planned IPv4. We are more mature in the cloud. We know how our workflow looks like, how many customers we need to accommodate in this environment. But also, for IPv6, you've got some fixed variables you need to take (156 VPC, each 56, and inside these VPCs, 256 subnets /64. It was tough. But we also thought about how the account shape is supposed to look like. And although the connected account, so account which provides connectivity with our resources on-prem, was quite popular, there were some use cases where users wanted to have a account which were more relaxed from security perspective, which allow them to do some experimentation, which allow them to do some tests, and in this case they didn't require this connectivity with internet, with our resources on-prem. As a result, we introduced connected and non-connected accounts, and resources inside. And what we did here, we added another seeder. You can have up to 5 seeders. Another seeder to this, quite big, /16. Of course, resources deployed in this new seeder were not directly visible from the outside, but it was not the case. The case was to deploy as much as possible resources, and that's why we selected the second seeder. And the third one, which is my favorite one, which I call the flavor, we don't know what we don't know. You know this. Doesn't matter how many architecture you build, there's always a use case which will not fit to your architecture. So instead of developing the new architecture every time when we've got some special use case, we did exactly the same what we did with networking guys. We took some pool we have, and we dedicated case is dual stack, and you can see this in subnets in the middle of this diagram. But it's no longer a case in AWS. You can have IPv6 only subnets. And don't get me wrong, dual stack is still can be done, but by using DNS64 and NAT64 technology, you can have IPv6 only nodes, but still you can interact with not only IPv6, but also IPv4 nodes. How it works? The node is connecting a DNS resolver, sending fully qualified domain name, but as a result, it doesn't get IPv4, it gets special IPv6 address. This IPv6 address is used to establish connection, and on NAT gateway level, we're doing translation v4 to v6 and vice versa. Another project, traffic inspection, gateway load balancer. You can see on this example 3 accounts on the left side. Think about this, that we are talking about hundreds of accounts and thousands of VPCs. Gateway load balancer with virtual appliances, which allows us to inspect traffic. And in this case, it's relatively easy to inspect traffic from, if you remember the concept of connected and non-connected accounts, it's relatively easy to inspect traffic from connected accounts because this account is already connected. But non-connected accounts, we need to build this connectivity. And this is what Corina mentioned about. We benefit with private link. As you know, private link is supported by gateway load balancers. So we literally build and this is the example for number 1 or 2. We literally build this virtual link using private links, and in this case, we are able to inspect traffic also from accounts who are not connected to our backbones. Now, a couple of words about future. We are evaluating a lot of systems. We are building POV, POC, whatever it calls in your organization. But it's worth to mention about Cloud One, and I will mention about Cloud One because of 2 reasons. One, because it's natural successor if you work in multi-transit gateway environments, if you're working in multi-transit gateway environments deployed across multiple regions with multi-route tables. It creates extra layer, which allows you to manage this, but there is something more. Cloud One supports policy as code. So you can move your DevOps skills, you can move your DevOps practices, which no doubt you're currently using in your company, and you can transfer to the networking, to the cloud networking route. Completely game changer from my side. Now, I would like to finish this presentation a little bit different. And Albert Einstein, which I believe I don't need to introduce you, a long time ago said, everything should be made as simple as possible, but not simpler. And this sentence fits perfectly to everything what we are doing here, but also fits perfectly to AWS services. Let's decouple this. Everything should be made as simple as possible. It sounds like AWS service. Easy to learn, easy to adopt, easy to understand, easy to inject to existing workflow. If I've got 20 minutes, and in 20 minutes I've got lunch with other architects, but I just found something on internet or AWS blog that there is some new feature, new service, I can still learn how it works. And I can sell this to my guys. I can still learn because it's easy, because the service has been made as simple as possible. But not simpler. It's still feature rich. It has a lot of options. It has a lot of elements which can be set, adjust, etc. But everything is hidden under AWS hood. If you are interested, you can deep dive to this ocean. But if you are me, and you've got 20 minutes, you can still understand the service because the service has been built as simple as possible and not simpler. Now, the reason why I'm telling this to you guys, and please take it as a takeaway, I would like to encourage you to be brave. I would like to encourage you to be brave to experiment. Create, destroy, recreate your environment. Apply your Ansible playbooks. Start your CloudFormation script. Execute your CI/CD pipeline. Destroy, recreate your environment. Why? Because you can. Because you've got portfolio, you've got whole ecosystem of AWS services which supports this functionality. Why? Because it's wise to do. Your architecture should be better than mine. I'm your competitor. He's your competitor, and she's probably your competitor as well. And the easiest, the fastest way to build this advantage is by experimenting, by building today something better you built yesterday. But there's one more thing. You should experiment because your customers deserve it. Your customers deserve it because from your perspective, they are the most important people on this planet. Ladies and gentlemen, my name is Radek Podezworny. I'm Director of Engineering Platform Architecture, working from ARM. It was a pleasure to be here. Thank you.
That's quite inspiring. Thank you, Radek.
You're welcome.
We have 1 more minute, enough to wrap up. Thank you all for joining. We went through quite a lot, so please don't take this as the full, complete overview of the AWS fundamental, but have a look at these 2 sessions from reInvent. We have one from the for the new to AWS track, AWS networking fundamentals. So you haven't started yet with AWS, please go first to that one. If you are quite seasoned to AWS, go to the advanced VPC designs. They are really good sessions. And please follow our blog post. We are launching new features, new services on the networking side every time. This is the blog post I'm always watching for. Even I can't keep up with AWS, how fast they launch stuff. Please bookmark them and have a look there. Thank you so much for today, for the first breakout of the day. Hope you have a nice day and a useful day today. Don't forget to rate our session, it's pretty important. And if any questions, please be free to come to us. In the next 15 minutes we'll be around, or there is a networking booth at the Ask an Architect. So wherever you want, we are here. Thank you.
Thank you.